Hello class. So let us go over a few more questions on optimization. So here it goes. Now, the number of bacteria in a culture. So basically, we are looking at this is the function that talks about the number. Now, the first question is this: find the largest number. So when we're talking about the largest, it implies the derivative, and number, we're talking about that function right over there. And smallest number. So once again, it talks about the minimum and number. That means we're looking at that function. Now, then, let us try to work on A. Well, now, since y is equal to 1000 times 25 plus t to e to the negative t over 20. Now, even though this expression looks somewhat complicated, but if you actually do it, it may not be that bad. First, I'm going to distribute 1000, 25,000 plus 1000 t times e to the negative t over 20. Now, when we take the derivative of that, y prime, the first 25,000 will become 0, and this one we just have to go for the product rule. So, here it goes. 1000. We could have t by itself times the derivative of the second portion, which would have been e to the negative t over 20 multiplied by the derivative of the exponent, which is negative 1 over 20, plus the other portion here would have been the second one, e to the negative t over 20 times the derivative of the first one, which is t by itself, which is 1. Now, but if you set this one equal to 0, we would have realized a couple of things. First, we realized that e to the negative t over 20 must be common in both terms. So when we factor out 1000 and e to the negative t over 20, then we are left with negative t over 20 by multiplying these two terms, and plus 1 is equal to 0. Now, then it seems to be that when you set this portion equal to 0, because this e to the negative t can never be equal to 0, so what we end up getting is this negative t over 20 plus 1 must be equal to plus 1 must be equal to 0, then we will realize that t must be equal to 20. Now, then t being equal to 20 must be one critical value in order for us to calculate the largest or smallest. We have to check upon not only the critical point but also endpoints. So in fact, what we'll end up doing is this. Since endpoints were t equals 0, t equals 20, and t equals 100. Here, we realize that these will be endpoints from the interval that's given way in the beginning, right over here. So then, let us plug those each values into the expression, which is right here, and then we'll figure out the rest. So first, when t equals 0, the number y becomes 1000 times, I believe it was 25 plus, okay, 25 plus some 0 times e to the negative 0 over 20. Now, here we realize that this portion becomes 0. Therefore, we are left with 2500. Now, second, uh, when t equals 20, we end up getting 1025 plus 20 times e to d, negative 20 over 20, which is simply equal to um, now here what I'm going to calculate is that this portion must be 20 times e. So since I don't have a calculator, I'm just going to go to the my browser. I'm just going to calculate 1000 times 25 plus 20 divided by e. I realized that it was about 32,357. So I'm going to write down 32,357.6. So that's about the value that we would have gotten. Now, the third one, 100, what we end up getting here is 25 plus 100 times e to d, negative 100 over 20, so which means e to the negative 5. Now what I'm going to do is I'm just going to calculate right here. So we end up getting 25, 134, so we have 25,134. So we realize here that this one becomes minimum, and this one becomes maximum. Now, the question is find the largest number, the smallest number of the bacteria. Now, so therefore, this one was the largest number, and this one was the smallest number. Right. Now let's go for B. At what time during the interval is the rate of the change of the interval minimum? Now, we're not talking about the number is the minimum, but the rate is minimum. That means rate is found by y prime, but y prime has to be the minimum. That means we have to find another derivative from this given y prime. Now, then, what we like to do is this. When we simplify this one, we end up getting this. So we're going to just pick it up from here. And then we're going to continue. So, here it goes. Okay. Since y prime was 1000 times e to the negative 20, or negative t over 20 times negative t over 20 plus 1. I believe that was the function. Now, what we like to do is to get y double prime, we're just going to do the product one more time. Then 1000, I'm just going to leave it alone. And then here we have e to the negative t over 20 multiplied by derivative of this, which is negative 1 over 20 plus, we're going to leave that portion as it is, negative t over 20 plus 1 times the derivative of that, which is e to the negative t over 20 times derivative of inside, which is negative negative 1 over 20. Now then we realize that this expression, all the way up to here, this expression all the way up to here, those are the two expressions that are common. So we're going to take those two things out, then we would have gotten something like this. Negative 1 over 20 times 1000, then it will get us negative 50 times e to the negative t over 20. Now, then we are left with here 1 plus negative t over 20 plus 1. Now, of course, if you have to simplify this one further, we'll end up getting negative 50 and e to the negative t over 20. And here we have 2 plus, or rather should I say minus, t over 20. Then we get to realize that when t is equal to 0, right here, 10, when t is equal to 10, oops, what I meant was when t equals 40, the y double prime is equal to 0. Now, then using a number line, we have 40, we have 0, we have 100. Those are the endpoints. So we want to test one here and here. But since this portion is always negative, and this portion will always be positive. Now, here, when we plug in the values less than 40, for example 10, then you will realize that this portion will be positive. So negative, positive, positive makes this portion negative. And here, if you plug in values greater than 40, then you will realize that this portion is also negative, which makes negative, positive, negative, which is positive. Now, they are looking for the minimum that you can see right here. I believe we found the minimum, which is negative to positive. So, when t equals 40, I believe in this case, the unit is, don't know, it's not given, when t equals 40. The rate of change in number of bacteria is the minimum. Alright, thank you, and we will continue with